Electric cars are getting more popular by the day. One reason for this is their electric motor. It's not only powerful, but also incredibly efficient. However, it can be difficult to understand how an electric motor works. Today we are going to demystify the science behind the electric motor, so that anyone can understand how these vehicles work. So stay tuned. An electric motor converts electrical energy into mechanical energy. The basic principle behind how electric motors work is quite simple. When an electric current passes through a magnetic field, it experiences a force. If we arrange the magnetic field correctly, this force will cause the motor's shaft to turn. That's why electric motors are sometimes called electric generators in reverse. And if you want to learn about how generators work, check out our video where we explain the science behind them. Let's take a closer look at the electric motor. At its heart, it's composed of two main parts: a stator and a rotor. The stator is the stationary part of the motor, while the rotor is the moving part. The rotor is attached to the motor shaft, which eventually connects to the car's wheels. Inside the stator are coils of wire that carry an electric current. As the current flows through these coils, it creates a magnetic field around them. Now let's bring the rotor into the picture. The rotor is a permanent magnet, meaning it has a north pole and a south pole. The magnetic field lines from the stator's coils interact with the rotor's magnetic field. Remember, like poles repel each other, and opposite poles attract each other. As the rotor spins, the magnetic field lines of the stator and the rotor interact in such a way that they exert a torque on the rotor. Torque is a twisting force that causes the rotor to turn. As the rotor continues to spin, the magnetic field lines shift, pushing the rotor until it reaches the next magnetic pole. This process repeats itself over and over again, causing the rotor to spin continuously. The beauty of this design lies in its simplicity and efficiency. Unlike an internal combustion engine, which has many moving parts, the electric motor has very few moving parts, making it extremely reliable. One of the remarkable things about electric motors is their high efficiency. They convert electrical energy into mechanical energy with minimal energy loss. In fact, electric motors are typically 85 to 95% efficient, meaning that a small fraction of the electrical energy used by the motor is lost as heat or noise. This efficiency is significantly higher than that of internal combustion engines, which are typically only 20 to 30% efficient. The efficiency of an electric motor depends on several factors, including the design of the motor, the quality of its components, and the load it is carrying. For example, a motor that is operating at its optimal speed and torque will be more efficient than a motor that is not. Additionally, factors such as friction and wind resistance can affect the overall efficiency of the electric motor. Electric motors are typically rated in horsepower or watts, which indicates their power output. The power output of an electric motor determines how much torque it can produce at a given speed. Higher horsepower means greater torque and faster acceleration. For example, a Tesla Model 3 with a dual motor, all-wheel drive has a total power output of 482 horsepower. This allows the vehicle to go from 0 to 60 miles per hour in just 3.1 seconds. In addition to their power output, electric motors are also characterized by their efficiency. Efficiency refers to how much of the electrical energy used by the motor is converted into mechanical energy. Electric motors can be highly efficient, typically ranging from 85 to 95%. This means that a small fraction of the energy used by the motor is lost as heat or noise. Overall, electric motors offer a compelling alternative to internal combustion engines for powering electric vehicles. Their high power, output, efficiency, and reliability make them an attractive option for drivers looking for a smooth, quiet, and environmentally friendly ride. You may be wondering what makes electric motors so much more efficient than internal combustion engines. Well, it comes down to several key factors. First, electric motors have fewer moving parts, which means less friction and less energy is wasted. Internal combustion engines, on the other hand, have many moving parts, all of which contribute to energy loss. Additionally, electric motors operate at much higher energy conversion efficiencies than internal combustion engines. In fact, electric motors are typically 85 to 95% efficient, whereas internal combustion engines are only 20 to 30% efficient. This means that a significant portion of the energy used by an internal combustion engine is wasted as heat, noise, and exhaust. Another factor contributing to the efficiency of electric motors is their ability to operate at optimal speeds and torques. When an electric motor is operating at its best efficiency point, it produces the maximum amount of torque for a given amount of electricity used. By contrast, internal combustion engines must operate at a wide range of speeds and torques to meet varying demands, which results in less efficient operation. Moreover, electric motors do not suffer from energy losses associated with processes like fuel combustion. No energy is lost in the conversion of chemical energy in gasoline to mechanical energy in an internal combustion engine. Overall, the efficiency of electric motors is a testament to the ingenuity of electric vehicle manufacturers who continue to develop new and innovative ways to improve the performance and sustainability of electric vehicles. As we delve deeper into the science behind electric vehicle motors, we encounter the fascinating concept of torque. Torque, simply put, is the rotational equivalent of force. Just as a force causes an object to accelerate in a straight line, torque causes an object to accelerate in a circular path. In the context of electric vehicle motors, torque is the force that causes the motor shaft to rotate. The torque produced by an electric motor is measured in Newton meters or pound-feet. A higher torque means that the motor can generate more rotational force, resulting in faster acceleration. For example, the Tesla Model S Plaid has a peak torque of 1,224 pound-feet, which enables the vehicle to go from 0 to 60 miles per hour in just 1.99 seconds. Generating torque in an electric motor involves the interaction between the stator and rotor components. The stator, which houses the motor's coils of wire, creates a magnetic field that interacts with the rotor's permanent magnet. When an electric current is passed through the stator coils, it generates a magnetic field that aligns with the magnetic field of the rotor. As the magnetic fields interact, they create a force that causes the rotor to spin, thereby generating torque. Torque is a crucial aspect of electric vehicle motors because it determines the vehicle's acceleration and driving experience. A high-torque electric motor provides instant torque, meaning that the vehicle can accelerate quickly from a standstill or low speed. This is particularly beneficial in situations where sudden bursts of acceleration are required, such as when merging onto a highway or passing another vehicle. The ability of electric vehicle motors to generate high torque is also important for driving uphill or in adverse weather conditions such as snow or ice. In these situations, the vehicle needs additional torque to maintain momentum and prevent it from rolling backwards. Furthermore, high-torque electric motors allow electric vehicles to tow heavy loads without struggling. This is important for drivers who use their vehicles for activities such as off-trailering or even daily commuting with a full load of passengers and cargo. Overall, the production of high torque is a key advantage of electric vehicle motors, providing drivers with a smooth, responsive, and efficient driving experience in various conditions. Hopefully, we've shed some light on the electric motor and how it works. It has truly amazing technology that makes electric vehicles such a great option for drivers who want a smooth, efficient, and environmentally friendly ride. Thanks for watching, and please don't forget to share your thoughts below.